So here we are again. We're back on chapter 9, and we are going to complete today the identification of the firm's competitive firm supply curve. And I want to go back to my whiteboard, so let me do that. We'll review for just a second what we talked about last time. So let me get to my whiteboard here somehow. All right, so here we are. And what we were saying in the last lecture in chapter 9 was that a firm will only operate if it can cover its avoidable costs. And what I was saying was that the firm's profit in this particular case was equal to the price that the market offers minus average avoidable costs times Q minus average sunk fixed costs times Q. And in this particular case, this was equivalent to, the market price minus average avoidable cost minus, quantity times average sunk fixed costs is just sunk fixed costs. And so, what I was saying was that if a firm produces zero output in the short run here, it's saddled with its sunk fixed cost regardless. So that if the firm chooses Q equal to 0, this is this is the worst case scenario for the firm, then its revenue is 0. So effectively, since quantity is 0, this term becomes 0, this first term. We're multiplying by 0. And in this particular case, then profit would be negative sunk fixed cost. And that's what the firm would have to bear in this short run period until it can make the long run adjustments to its fixed input to eliminate those sunk fixed costs. Now, if, on the other hand, if price, we said, is greater than average avoidable costs, then this term, price minus average avoidable costs, is positive. So in this particular case, profit would be equal to, assuming again, Q is positive, so the firm will produce. Profit will be equal to, price minus average avoidable cost times Q minus sunk fixed cost. And since this term here is positive, this profit will be greater than the profit the firm would earn if it shut down. In other words, if Q were 0. So the firm will operate if the market price is at least as great as its average avoidable costs, and that would imply then that price, for operation to be assured, that price would have to be greater than minimum average avoidable costs for the firm to operate. Note that if I didn't make this point last time, but if price were less than average avoidable cost, then that means that this term, price minus average avoidable costs, would be negative. So in that particular case, I would have profits of price minus average avoidable cost times Q minus sunk fixed cost, but now this term is negative if Q is positive, so that profits by operating when price falls below average avoidable cost would actually be less than the sunk fixed costs. So the firm would definitely prefer just to lose its sunk fixed costs. It doesn't want to add fuel to the fire by also losing money against its avoidable costs, by losing profits against its avoidable costs. So that's why we said that our supply for the firm then, and this is what we want to do today, supply for the firm in our supply curve is going to be price equal to marginal cost for price that is at least as great as minimum average avoidable cost, and or its output equals zero if price is less than a minimum average avoidable cost. Obviously, it'd be indifferent if price was exactly equal to minimum average avoidable cost. But this isn't a supply curve right here. So this is what we want to do today. We want to express the supply curve in terms of, the relationship between quantity supplied by the firm as a function of price. Now, let me think about how I'm going to do that. Let me draw this out again like I did the last time. So I got my firm here who has, the usual set of supply curve, of average cost curves. So here's my average total cost curve. Here's my average avoidable cost curve. These curves get closer and closer together because this vertical distance, which is average sunk fixed cost, decreases as Q increases because sunk fixed costs are constant, and as Q increases, then the average falls. And then we have this third curve, which is an average variable cost. And then our marginal cost curve, as we argued, goes through each of those at their minimum point. So by our logic so far, what do we have? We've got that the firm will operate only as long as, and by operate I mean choose a positive output quantity, only as long as price is at least as great as minimum average avoidable costs. And the firm will always choose its output to equate marginal cost to price. So in essence, the marginal cost curve is now going to become the firm's supply curve when the firm chooses to operate. Once price falls below minimum average avoidable cost, then the firm's output becomes zero. So when I have a firm that has this cost structure here, it's going to have a supply curve that is discontinuous. That is to say, Q will be zero for, and let me call this, P prime here, that's that price, for any P, for any market price less than or equal to P prime. And Q will be positive, and this is what we want to derive the equation for any P that is at least as great as P prime. And this relationship is what I want to observe here. I want to focus on this area of this section of the marginal cost curve above that minimum average avoidable cost. So let's look at this. Let's take an example out of your textbook here and come up with the supply curve. Here is the problem that's on page 292 of your textbook. It's a worked out problem. And so we'll do two here. We'll look at this. This is on page, as I said, 292. And that's why we spent all the time in the last chapter on costs looking at the methods for finding minimum average costs. So this becomes an important term for us. Anyway, this question says that Dan's Pizza Company has a daily cost of producing pizzas of 5Q plus Q squared over 80. And that generates for us a marginal cost of 5 plus Q over 40. Now, notice there is no fixed term here. There is no fixed cost term. So all costs for Dan are variable with this particular formulation. So average, well, let's just say rather variable costs is what I want to do here. So all costs are variable. So variable costs are going to be simply, the total cost of Q divided by Q. So it's going to be C over Q. So that will be 5 plus Q over 80. Now, if this is Dan's variable cost function and he has no fixed cost, this is average variable cost, I'm sorry. This will also be Dan's average avoidable cost because he only has variable costs, so all costs are avoidable. So how do I find minimum average avoidable cost? Well, I set marginal cost, 5 plus Q over 40. I'm going to set that equal to average avoidable cost, which is 5 plus Q over 80. And I'm going to solve for Q. So the 5s are going to cancel. I end up with Q over 40 is equal to Q over 80. That can only be true, is only possible if Q equals 0. So Dan's minimum average avoidable cost, not surprisingly, without any fixed cost, minimum average avoidable cost at Q equals 0 is, well, 5, right? Is 5, because I stick that Q back into Dan's average avoidable cost, which is 5 plus Q over 80, but if Q is 0, then it's 5 plus 0. So minimum average avoidable cost occurs at Q equals 0, where price, this implies, and let me change this, implies then that average avoidable costs, that minimum average avoidable cost is equal to 5. So Dan will require at least a price of 5 to operate. Now, what is Dan's supply curve going to look like? Well, here's Dan's golden rule. Dan is going to choose Q such that price is equal to marginal cost. But what's marginal cost? Marginal cost, we said, was 5 plus Q over 40. So what do I have here? I've got, this tells me then that P minus 5 will be equal to Q over 40, or Q will be equal to 40P minus 200. So this is Dan's profit maximizing quantity at every price that is at least 5. And as you can see, actually the price of 5, Dan's output is 0. But for any price less than 5, Dan's output will be 0. So this is Dan's supply relation when Dan has no fixed costs. Now, the question goes on to say, well, what if he also has an avoidable fixed cost of $8.45 per day? So if he has an avoidable fixed cost of 845, Dan's cost function now becomes 845 plus 5q. I have to add the variable portion to that now, plus q squared over 80. Right? So what do I have here now? I still have marginal costs. The addition of fixed cost is not going to affect my marginal costs. So marginal cost is still going to be 5 plus q over 40. But now, this is an avoidable fixed cost. So average avoidable fixed cost now would be 845 over q plus 5 plus q squared over 80. Where is minimum average avoidable cost now? Same deal. I set marginal cost. I need to find minimum average avoidable cost. And I do that by identifying the intersection between the marginal cost curve and the average avoidable cost curve. So I've got 5 plus q over 40. I'm going to set that equal to 845 over q plus 5. This isn't squared here. This is just a q. Plus q over 80. Right? So this is marginal cost. This is average avoidable cost. Once again, these are going to cancel. I want to move this to the left-hand side. So what do I have here? I've got 2q over 80 minus q over 80 is equal to 845 over q. So I've got q over 80 is equal to 845 over q, or I've got q squared is equal to 80 times 845, right? And let's do that algebra. So I've got 80 times 845, which is 67,600. I need to take the square root of that, and I get 260. So Q equals 260 is where minimum average avoidable cost occurs. So I need to come now to my average avoidable cost. I've got 845 over Q plus 5. So minimum average avoidable cost is going to be 845 over 260. Q equals 260 plus 5 plus 260 over 80. And that comes out to be equal to 11.5. So in this particular case now, Dan's supply curve is, well, Dan once again is going to set price equal to marginal cost in order to maximize profits. And we said that that works out to 40p minus 200. Now in this particular case, this is going to be only for a price that is at least 11.5, which is minimum average avoidable cost once we add that avoidable fixed cost. Or Dan will choose to shut down and earn zero profits for price less than 11.5. All right, so what do I have here actually now? You know, in the first case with no avoidable costs, with no avoidable fixed cost, all of Dan's costs were variable, and we said that Dan needed in that case to get a minimum price of 5. This is his average variable cost or average avoidable cost, equivalent in this particular case, reaches its minimum point at 5, which means that it coincides with marginal cost here. We said that Q equals 0, and marginal cost then is everywhere higher, so average avoidable cost is rising. Remember, marginal cost was 5 plus Q over 40, whereas average avoidable cost was 5 plus Q over 80. So marginal cost will be everywhere greater than average avoidable cost for any Q positive. So average avoidable cost is rising. Now with the avoidable fixed cost of 845, now what we have here is a fixed cost, which is added into the relationship. So, you know, I still have the same marginal cost. We said 5. Here's my marginal cost curve. But now my average avoidable cost also has a fixed component. So it's going to look like this. So this will be my average avoidable cost, which also includes that 845 as a non-sunk or an avoidable fixed cost. Now, this was my supply curve. In that case, with no avoidable fixed cost, it was Q equals, what was it, 40p minus 200. And this is the exact same curve over here. Note, this is still Q equals 40p minus 200. But in this case now, for any price less 11.5, Dan produces 0 pizzas when he has to cover that 845. Whereas over here, there is no discontinuity. The curve starts at Q equals 0. In this particular case, if I were to redraw this, I would say, okay, let me just draw the supply curve here. Dan's supply curve with this avoidable fixed cost would be this, 11.5. And at the quantity, let's put in Dan's supply curve, that price of 11.5. So I've got 40 times 11.5, just solving for Q at this point of price equal 11.5. So I have 40 times 11.5 minus 200 is 260. So Dan's supply curve will become positive at a price of 11.5 and a quantity of 260. And Dan will be on that marginal cost or supply curve for any quantity at least 260 or greater. But since we're looking at a supply curve, we want to think of it in terms of price. Here's another problem here in the text. So I didn't draw it on the one I wanted to draw it on. So here's Dan's supply curve at 260. Right here, 11.5. Dan's supply curve looks like that. And it's 0 for anything, for any price less than 11.5. So there's this discontinuity in Dan's supply. It goes up this axis at 0, and then it skips over here and Q becomes positive at P, at least 11.5. There's also, in the text, there's another one that says, what is Dan's supply function if he has a daily variable cost of Q squared over 2, a marginal cost of Q, and an avoidable fixed cost of $50 per day. So this is the in-text exercise on page 293. So it says Dan's supply function has a daily variable cost of Q squared over 2. That yields a marginal cost of Q and an avoidable fixed cost of 50. So an avoidable fixed cost equal to 50 per day. So what is Dan's cost function going to be composed of? It's going to be composed of the 50 avoidable fixed cost plus the variable cost Q squared over 2. Now, these are all avoidable since that 50 is avoidable. I need to treat it as such, and so I would get an average avoidable cost of 50 over Q plus Q squared over 2 over Q, which is just Q over 2. Now, once again, in order to get Dan's supply function, I have to determine the price that Dan has to get to choose to operate. And so what I need to do is I need to find minimum average avoidable cost, and I do that by set 50 over Q plus Q over 2 equal to marginal cost, because marginal cost intersects it at its minimum point. So what do I have here? I've got Q over 2 minus Q over 2, Q minus Q over 2 rather, is simply equal to Q over 2, and that's equal to 50 over Q. So what does that tell me? It tells me Q squared is equal to 100, 2 times 50. So Q equals 10. So it's good to know Q equals 10 at minimum average avoidable cost, but I don't care about Q so much as I care about minimum average avoidable cost. So I have to stick that in. What is minimum average avoidable cost? Well, it's going to be 50 over 10. So minimum average avoidable cost then is 50 over 10 plus 10 over 2. That looks like it's also 10. So Dan now will only supply positive quantities for a price greater than 10. And what do I do to find Dan's supply curve? Well, I go back to the marginal cost curve, which is just Q. So I have price is equal to Q. This is price, and this is marginal cost. Or Q will be equal to P for a P at least 10. Q will be equal to 0 for any P less than 10. So what do I have here? Again, I've got this discontinuity introduced by the presence of the fixed costs. So Dan has to get at least 10. And we've got a very easy supply curve here. So if once price hits 10, Dan produces 10 pizzas. That means then that Dan's supply curve will be just linear, Q equals P. So this is Dan's supply curve, quantity supplied equals P for P at least 10 equals 0 down here for P less than 10. All right. Now notice, Dan's selling 10 pizzas at $10 each, then Dan's average avoidable cost is 50 over 10 plus 10 over 2, which is 10. And Dan then covers his avoidable fixed cost with those pizzas there. All right, so let me come up here for just a second. So at Q equals 10 then, Dan is able to cover his $50 in avoidable fixed cost, plus at 10, his variable costs are 100 over 2 or 50. So Dan exactly covers his avoidable costs at that price of 10, selling 10 units. And so this is Dan's supply curve, graphically, and this is it then expressed algebraically. All right, this is the way you do them all. Now, here's an important point here. Ignore sunk costs. Sunk costs are totally irrelevant to this question because sunk costs, once made, can't be recovered. So forget about them. As we said, the only thing we're concerned about is covering our avoidable costs. As long as we can cover our avoidable costs, then we'll go ahead and operate. Sunk costs don't enter the equation. So if I came back to this problem, this in-text problem here that says, Dan's supply function is, variable cost, back to Dan's pizza place. He has a variable cost of Q squared over 2. So that generates this marginal cost equal to Q. Now suppose that sunk fixed costs, boy, does that look like a mess. Let's get rid of all that. That Dan's sunk fixed costs, it's so hard to write on. Sunk fixed costs equal 50. How would I figure out Dan's supply function here? Well, his sunk costs don't enter into my thinking here. There's nothing I can do about those. So once again, I would just be back to average variable costs equal Q over 2, and marginal cost equals Q. This is also note avoidable costs. So average avoidable costs, go back to our notation. Average avoidable costs would be equal to Q over 2, since the only avoidable costs in this particular case are the variable costs. And so I would have Q over 2, average avoidable cost equal to marginal cost. Q tells us that can only happen at Q equals 0. So we're right back where we were before. Now, minimum average avoidable cost in this case is equal to 0 over 2, or 0. So what do I end up with? I end up with now a supply function that looks like Q equals marginal cost here. We say is Q, so I said price equal to Q, so I would have Q equal to P for, in this case now, minimum average avoidable cost occurs at 0, so I would just have this supply relationship. And if Dan were selling, less than 10 pizzas, in this particular case, suppose that Q equal 5, then Dan would have a variable cost of 25 over 2. This would occur at a price of 5. So Dan would have a variable cost of 25 over 2, but his fixed cost would be 50. His avoidable fixed cost would be 50. So he would have a total, it's 25.5. So he would have a total cost of 75.5. But he would have revenues, price times quantity, equal to 25. So Dan would be losing in that case. His profits are minus 50, which are exactly his sunk fixed costs. Okay, so Dan's going to lose. His profits would be 50.5. So Dan is going to lose a little bit in excess of his sunk fixed costs, but that shouldn't be. Let me think about what I've just done here. I shouldn't do these things on the fly. So P equals Q, so at price of 5. So Dan's variable costs at that point, we said 25 over 2, I'm sorry. Variable costs are 12.5. That's where I went wrong. 12.5. So his total costs are going to be 62.5. So 62.5 minus 25, how much is that? So Dan's profits are minus 37.5, but that's better than minus 50. If he shut down, his profits would be minus 50. So he is covering his avoidable cost, in this case, they're all variable costs, by his selling 25 units. And notice, his variable costs, his on operation here, or, his, revenues equal, we said 50 or 25, excuse me, 5 pizzas at $5 each, and his variable costs are 12.5. So he's at least making 12.5 by operating that he can use to offset his $50 in fixed costs. So that's why he would operate. Even though he's losing money, he loses less money by operating in this scenario than by shutting down. Now, I'll let you guys read, changes in input prices. I want to come back to, I want to do a, so then I don't want to talk about the short run versus long run right now, but we will talk about that when we get to chapter 14. For now, let's talk about a final topic here in this chapter for us, and that is producer surplus. This is the counterpart to consumer surplus on the firm side. And what producer surplus is by definition, producer surplus is equal to revenues minus avoidable costs. And so this really reduces our shutdown rule to the firm will operate, Q will be positive if producer surplus, Q is positive if producer surplus is not negative. Q will be equal to 0 if producer surplus is negative. That is to say, if the firm were to operate and it was not able to cover its avoidable costs, then producer surplus would be negative. So maybe let me add a Q positive there. So basically, revenues minus avoidable costs for a competitive firm, the producer surplus then is equal to P times Q minus avoidable costs or it will be positive if P times Q is greater than avoidable costs, which is the same as saying if price is greater than avoidable cost divided by Q, which is average avoidable cost. So producer surplus is the measure of the revenues the firm generates over and above its avoidable costs. Now, if I think about this graphically, consider a firm with no fixed costs. So all costs are variable costs, only variable cost, right? So we just did one of those. We'll go back to Dan's Pizza. We said had to get a price of 5, but if it got the price of 5, then this became a supply curve. So this was now its marginal cost curve, and it's if it had a price of whatever, then moving along the supply curve as a price greater than 5, then Dan would produce this many pizzas. And to find now the producer surplus, I would recognize that on the first unit, it would be price less marginal cost for that unit. On the second unit, producer surplus would be, again, market price less marginal cost of the second unit, the third unit, and so on. So what this total producer surplus would be is then the distance, or the area, I should say, between the price line and the marginal cost curve, right? It's marginal cost curve, not the average variable cost curve, right? Because in this particular case, Dan will be producing along his marginal cost curve, and that becomes a supply curve. So this area here, this is no fixed cost. It's the distance between Dan's supply curve, which is also his marginal cost curve, and this price line. Now suppose that there are some avoidable fixed costs. So when we have avoidable fixed costs, we said that, what did we say? We said that Dan now was only going to produce at a price of 11.5. Here's Dan's marginal cost curve, same as before. And here was Dan's average avoidable cost curve that reached its minimum right there, 11.5. It's not a very good drawing. So this is marginal cost, this is average avoidable cost. And we said this is Dan's supply curve. 0 for any price less than 11.5. And then it became positive. What did we figure out that quantity was? I don't remember what we figured out the quantity here was, but what did we figure out? Let's put it in there. Oh, 260. All right, so we set it 260. Now, this makes Dan's supply curve look like this. At 260 and 11.5, Dan's supply becomes positive. So here's Dan's supply curve. Now, how am I going to find the avoidable cost in this particular case? Well, it's going to be, like I did before here, I figured out the area between the price and the marginal cost line, because it was this area down here that qualified as total variable cost. So remember, if I add up marginal costs up to Q, I add up the marginal cost of each unit of output up to Q. What do I have here? I have total avoidable costs. But down here, it's a little tougher. I need to figure out what total avoidable costs look like down here. Well, suppose the price is, 14. So what I need to get here now is I need to recognize that this area right here, as we worked out, this is total avoidable costs at Q equals 260. So I have this rectangle here, 11.5 times 260 is total avoidable cost. So that would be the sum of Dan's fixed cost, 845, I believe it was, and his variable costs. Then I have this additional little, revenue over and above those total avoidable costs, so that my producer surplus in this case would be this area above this horizontal line 11.5, and then I need to take into account the marginal cost of all the units greater than 260. So I need to add those in. So this becomes my total avoidable cost here, this area. Let me change color. This becomes my total avoidable cost here. I've accounted for my avoidable fixed costs in that rectangle, plus the variable costs that occurred up to 260. And then I need to just add, since my avoidable fixed costs are fixed, I only need to add the marginal cost of those units in excess of 260 to reach my total avoidable cost. So this entire area here is total avoidable costs. And then this rectangle here is my total revenue. So I'm left then with this area in here, which is producer surplus. I'll work some of these problems for you on the next class meeting. We'll calculate some values for actual consumer surplus, and hopefully that'll make that clearer. I didn't feel like that was a very good discussion. So I will see everybody, well, some of you at least, in the next class meeting, and we will work these problems out. So until then, bye-bye.